Formation of crystalline solids, molecular solids. As the name suggests, the constituents of molecular solids are molecules. They are of different types. Non-polar molecular solids. The molecules of non-polar molecular solids are formed by non-polar covalent bonds. The molecules are held together by very weak dispersion forces, also called London forces, which are easily overcome by thermal energy at room temperature. Hence, they exist as solids only at very low temperatures. They are soft. They do not conduct electricity because of lack of free electrons. Polar molecular solids.
Some molecules like HCl show polar character because of the difference in electronegativity of H and Cl in the HCl molecule.
Each molecule behaves as a dipole, and due to this dipole-dipole interaction, the molecular attractive force is a little stronger. They have a higher melting point as compared to non-polar molecular solids, but are still liquid or gases under room temperature and pressure. Ionic solids. Ionic solids are formed between highly electropositive and electronegative elements. Let us see the structure of sodium chloride. Sodium chloride is our ordinary household edible salt. The sodium ions and the chloride ions are held together by strong electrostatic forces of attraction. Due to this strong force, they are hard and have a high melting point. They do not conduct electricity as the ions are fixed, but when they are dissolved in a solvent like water, they become free to move and thus conduct electricity. Hence, salt water will be a conductor of electricity. Metallic solids. Metallic solids can be explained by the electron C model. The structure is an orderly collection of positive ions, and there is a sea of free electrons that are spread throughout the metal crystal. Each atom contributes one or more electrons. These free electrons are responsible for high electrical conductivity. They are also responsible for high thermal conductivity. Metals also have luster. They are malleable, that is, they can be drawn into sheets. They are also ductile, that is, they can be drawn into wires. Covalent or network solids. Non-metals form a wide variety of crystalline solids by the formation of covalent bonds throughout the crystal. A diamond is an example of a covalently bonded solid. Due to the strong and directional nature of covalent bonds, the atoms are held rigidly at their positions. Such solids are therefore hard, brittle, and have extremely high melting points. They do not conduct electricity as they have no free electrons. Graphite is also an example of a covalent solid, but it has some exceptional properties. As seen in the structure, the carbon atoms are arranged in layers. Each atom is covalently bonded to 3 other atoms in the same layer. Yet another 4th valence electron is delocalized and is free to move along the plane, which gives electrical conductivity. The different layers can slide over one another, and hence the use of graphite as a lubricant is generally made.